In Unit 12, Part 3, we are looking at our third way to solve systems of linear equations. We solved by graphing, we solved by the substitution method, and now we're going to solve by the elimination method. So the elimination method says that one variable is eliminated by adding or subtracting the two equations to obtain a single equation in one variable. So just like with the substitution method, our goal is to get one equation that only has one variable. We don't want to be in two variables. So there's also 3 steps for this one as well. The first step is to add or subtract the equations to eliminate one variable. Again, remember, we only want to be working in one variable. The second step is to solve the resulting equation for the other variable. So when we add or subtract, our goal is to get rid of one variable. So we're going to solve for the one that's left over. And then the third step is to substitute the variable into either original equation to find the value of the eliminated variable. So step 1, we're going to eliminate one of the variables. Step 2, we're going to solve for the other one, the one we didn't eliminate. Step 3, we're going to go back and find the eliminated variable. So let's look at some examples. So it says solve each system of linear equations by adding. So if you look at our first example, I'm going to go ahead and rewrite these just so they're easier for me to work with. Okay, so I already told you that we're going to be adding them. The reason why we're going to be adding is because if you look, we have a positive y and a negative y. So when we add those together, they're going to eliminate each other. So that's why we want to add, because we have a positive and a negative. So if we just add down, x plus x is 2x, y plus negative y is 0, and then negative 1 plus 7 is 6. So then I need to solve 2x equals 6, so I'm going to divide by 2 on both sides, and I'll get x equals 3. So that was step 1 and step 2 all kind of wrapped into one. So step 1 was to get right here. I eliminated the y, so I have x. Step 2 was to solve for the variable that wasn't eliminated, just sort of solve for x. So then my third step is to take x equals 3 and plug it into either one of these original equations. So I'm going to plug it into the first one. So I'll get 3 plus y equals negative 1. I would subtract 3 from both sides. So I get y equals negative 4. So that's my third step, is to plug it into either equation and find the eliminated variable. And then again, since it's a system, my answer is going to be in ordered pair. So in this case, that'd be 3, negative 4. Make sure you have those notes down because I'm going to go ahead and erase this. On number 2, I'm going to start by rewriting these again. I'm going to slide over to the left a little bit so I have some more room. Now again, the section heading already tells you what I'm going to add, but again, look, the reason why I'm going to add is because I have a positive 6x and a negative 6x. If I add opposites, I wind up with 0, which is my goal. So step 1, I'm going to add the equations, or subtract, in this case, add. 6x plus negative 6x is 0. 5y plus 7y is 12y. 4 plus 20 is 24. So that's my first step. I've eliminated the x. Second step is to solve for the variable that I didn't eliminate. So I'm going to solve for y, and I'll get y equals 2. Third step is to plug that into either equation, either of the originals, to solve for the eliminated variable. So I'm going to plug it into the top equation, and then I can solve for x, which is what I originally eliminated. So I have y as 2 and x is negative 1. It's system, so my answer is an ordered pair. In this case, it's negative 1 and 2. So that's my solution. So in this first section, we solved by adding. In the second section, we're going to solve by subtracting. So again, I'm going to start by rewriting my originals. So 6x minus 3y equals 6. 6x plus 8y equals negative 16. Now, for this one, the directions tell you to subtract. The reason why I want to subtract is because I have a 6x and a 6x. They're both positive. So if I add those together, I would get 12. So I'm not going to add this time. I'm going to subtract. So I put a subtraction sign out in front of all of this. So 6x minus 6x is 0. Negative 3y minus 8y is negative 11y. Make sure you keep track of your subtraction. Negative 3y minus 8y is 11y. Then I have 6 minus negative 16, which is 22. So let me break those down for you. I did negative 3y minus 8y and got negative 11y. Then I did negative 6 minus negative 16, so plus a positive 6 minus negative 16, which became plus a positive, so that's how I got 22. Okay, so that's step 1. Add and subtract to eliminate a variable. Did that. Second step is to solve for the variable that I did not eliminate, so I get y equals negative 2. And then my last step is to plug that into either of the originals to solve for the eliminated variable. So I eliminated x, now I'm going to plug it back in to solve. So 6x plus 8, I replace the y with negative 2, equals negative 16. So 6x minus 16 equals negative 16. Add 16 to both sides. I get 6x equals 0, which just means that x equals 0. So I have an x and a y. I'm solving a system, so my answer is the coordinates 0, negative 0. Alright, I'm going to let you guys try number 2 on your own. Okay, when we get to the backside, it gets a little bit more confusing. Okay, it says solve each system of equations by multiplying and adding. Okay, so let's get into this and I'll explain why we have an extra step. I'm going to start by rewriting them. 5x plus 2y equals negative 10. And 3x plus 6y equals 66. I'll probably wind up all over the place, so I can fit this all in here. Now, if you look at this, the 5 and the 3 in front of the x's doesn't work out. The 2 and the 6 in front of the y's don't match up. Okay? So I've got to have the same coefficient on either my x or my y for this to work. So I'm going to say that I could either make the x's the same or the y's the same. I'm going to choose to make the y's the same, which means I need the coefficient to be 6. Now, what's going to make it even easier is if I make one of them negative 6. So what I'm going to do is multiply everything on this top equation by negative 3. When I do that, I get negative 15x minus 6y equals positive 30. If I then put my other equation underneath it, hopefully that'll make sense. So now I have a negative 6y and a positive 6y, so I can add these together to eliminate them. So negative 15x plus 3x is negative 12x. Negative 6y plus 6y is 0. 30 plus 66 is going to give me 96. Now I can solve for x, so I can divide both sides by negative 12, and I'll get x equals negative 8. My last step is then to plug this into either of the originals and solve for 1. So I'll do the top one, so 5 times negative 8 plus 2y equals negative 10. So that's negative 40 plus 2y equals negative 10. Add 40 to both sides. I get 2y equals 30. Divide by 2, y equals 15. Again, my answer is in ordered pair. So I have negative 8, 15, that's my answer. So that's my ordered pair. Alright, go ahead and get this written down because I'm going to erase it. Okay. Number 2, I'll leave for you guys to try. Remember, you want your coefficients to either be the same on the x or the y, and you're going to have to multiply to do that. Alright, looking at the last section, it says solve each system by multiplying and subtracting. So again, I'm looking to have coefficients that are the same. So I'm going to start by rewriting 3x minus 7y equals 2, 6x minus 9y equals 9. Now I either want the number in front of the x's to be the same, or the number in front of the y's to be the same. I can look at this and see that I know 3 can be multiplied to get to 6. So I'm going to go ahead and multiply everything on the top by 2. So I'm doing the distributive property to everything. Okay? Or I'm not really doing distributive property, I'm just multiplying everything by 2. So when I do that, my top equation becomes 6x minus 14y equals 4. And put the second equation underneath it. And now if you look, I have a positive 6x on the first equation and a positive 6x on the bottom equation. So I can go ahead and subtract here. So 6x minus 6x is 0. Negative 14y minus negative 9y turns into plus a positive, so I'll get negative 5y there. And then 4 minus 9 is negative 5. Then I can divide both sides by negative 5, and I've solved for y. Y equals 1. My last step is then to plug the y into either equation so that I can solve. So I'm going to do the second equation, 6x minus 9 times 1 equals 9. So 6x minus 9 equals 9. Add 9 to both sides. 6x equals 18. Divided by 6, x equals 30. Again, it's a system. So my answer is in ordered pair, 3, 1. Alright, I'll leave number 2 for you. Again, I know this is probably pretty complicated, so just ask questions.